let me help you get an idea of what to do when we have degrees and radians. We've talked about radians and we've talked about the degrees, and so now we kind of have to figure out, well, what do we do when we got one but we want the other? How do we connect the two? How do we translate one to the next? And so walk with me through this real quick as I kind of help build the idea for that. So remember, to find our radian, we took its distance around the circle and divided by its radius. So let's assume that we're going to take the distance around the entire circle. And if we remember the distance around the entire circle, or its circumference, we remember that was being 2 pi r was its entire distance. So I've followed along with my model that I have here. Distance around the circle divided by its radius. And then I can see that the radiuses drop out, and then I'm left with the distance around in radian is 2 pi. And that will help us because we know that the degrees around an entire circle, where I'm going to write, I'll back it up over here. Sorry, folks. We know that it's 360 degrees around the entire circle, which is 2 pi. And then if I reduce that down, I'll get 180 degrees equals pi. And that's going to be a very useful relationship that we can use over and over again, is that we know the distance of pi is 180 degrees when we're thinking about angles. So for example, let's say I want to convert 30 degrees into radians. Well, I'm going to need to look for some type of relationship that I can use to help translate or transition from degrees to radians. And since I know I have this relationship right here, I'm going to take 30 degrees, multiply it. In this case, I'm going to multiply it by pi over 180 degrees. And I know that's the first time we're seeing that, so let me just pause for a moment and kind of remember, where did that come from? Well, if I know 180 degrees equals pi, I know that if I ratio those, the ratio is going to be a clever version of 1. And anytime I multiply any number by 1, or a clever version of 1, I have the same thing. It just might be listed in a different language or a different translation. And so in this particular case, I'm going to use that clever version of 1 to help me go from degrees to radians. So multiplying this out, you'll notice that degrees cancel. I'll have 30 will equal 30 pi over 180. And then I can divide 30 into 180. And that's going to get me, what is that, going 6 times? That looks like it'll give me pi over 6. And so I converted 30 degrees by using a clever version of 1, did the math, and got his translation to being pi 6. Many of us are going to want to use our calculator and use its decimal approximation of pi and take 30 times 3.14 blah 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 and get some type of a decimal response. That's not going to be helpful for us as we continue on. An answer that's left in pi, that's an exact form that we're going to be able to work with. So I encourage you, it's all right. Just leave it as its pi form if pi isn't an answer. Don't resist the urge. Resist the urge to have to get an exact decimal answer because, well, it's not really an exact decimal answer. It's an approximation, as opposed to this, that is an exact answer. And so that's going to be one of the hard things for us to get used to, is leaving things in radian measures that just have a pi on it. Excuse me. All right, let's look at another example. Let's go from radians to degrees. And it's going to be the exact same idea. Whoops, sorry. Let's do that with, that wasn't helpful. So I have -5 pi over 3 radians. And I need to multiply that by my conversion that I've discovered. And I remember again, if I go back, that 180 degrees equals pi. I think I can use a relationship that's there. I don't think I can use the one I used before. That was pi over 180 degrees. And if I use that same one, I don't think I would get anything to cancel out and be left with just degrees. So I'm going to use its other clever version of 1, which is 180 degrees, all over pi. That's also a clever version of 1 because we know 180 degrees is the same as pi in its angular measurement. And then from here, I can see that pi cancels. And then I'm left with -5 times 180 all over 3. And that equals 180 divided by 3 is 60. 60 times -5. Looks like that gives me -300 degrees. Yeah, because we went from radians and then we moved ourselves on into degrees. So anyway, I hope that was helpful to give us an idea that we can go from degrees to radians, or we can go from radians to degrees. And the key fact in knowing that is this relationship that we discovered, that 180 degrees equals pi.